Okay, hey, so you want to learn how to program microcontrollers. And let me just get into it. We're going to be using C, the programming language C, just the letter C. And let me go over some of the design flow. So your microcontroller is going to have registers, and these registers hold ones and zeros in them. So let me draw these sections for the bits. So you might have a 1 here, a 0 here, 1, 1, 1, 0, 100 or something like that. This register is going to be located at an address, and that address is usually in hexadecimal number representation. That could be any symbol from 0 to 9 and A to F. So you can have A, 9, F, C, 3, 6, 8, 7. That'll be 8 bits, 16 bits, 24 bits, 32 bits. So this is a 32-bit address. The reason why we have the address is so that we can point to this register using something called a pointer. So we take a pointer, we set what it points to this address. Then we can set this pointer variable to any number, and when we do that, we're setting the register to that number we wanted. So I know that let's see how many bits is in this register. 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's just go with 8, so I'll erase 1 here. Which means that we can set a value from 0, 0, 0, 0, 0, 0 in all the bits places, or 1, 1, 1, 1, 1, 1, 1, 1, 1. The number 1, 1, 1, 1, 1, 1, 1, 1, 1 is probably pretty large. It's 2 to the power of 8. I don't know what this is in my head. 2 to the power of 8 is 256. Okay, so that's the biggest number we can put in here. So if we set this pointer, set pointer equal to 256 in decimal numbers, so in regular numbers, and we will be setting this 8-bit register to 11111111. But that's the general principle. So a simpler example would be, why don't we just set it to 2? So that would be 0, 0, 0, 0, 0, 0, 1, 0. Now here comes the main part about programming microcontrollers. This 1 that we just set could be controlling something. So registers control the behavior of the microcontroller. So you will have registers. They will be set at various addresses. This is a long and complicated address. You won't remember this address. But you can set a macro that will be a name for your address. So you can just go GPIO address. Let's just go that. You can set that equal to this number using a macro. Now, whenever you type in this, your pointer is gonna know, okay, this is the address we're pointing to. So that's a great thing about C, is you can set a macro so you don't have to recall this long address. And you can also give it a specific purpose. So this number actually is the GPIO address. So you can now point to the registers that are related to GPIO, general purpose input output behavior, and toggle those bits on and off and control the behavior that way. So a lot of the initial setup for a microcontroller is finding in the datasheet where the registers are and what bit positions do we want to have, a 0 and 1 to get the functionality from the microcontroller that we want to have. So that's kind of the flow of the initial setup of the microcontroller. And let's program in C. So let's just go to your trusty desktop, just open a new text document. You can call this my C program. You can open this up. It should be empty. Created a new text document. And in here, I just go int main, parenthesis pair, curly bracket, pair, and boom, here you are. You just wrote a C function. This is your main function, and this is what will run. The main function is what will run when you compile this and run it on a microcontroller. You can also return here 0 and then semicolon. Now what you've done is you're returning an integer, which is what this int was requesting, and you're saying, hey, at the end of this function, return a 0. So if main evaluates to 0, we're good. You can put 1, you can put -1. That's just going to evaluate to a different number and return that number. Usually what you'll see is you'll see hash include and then quotes, and in these quotes you'll have the name of another file. These files are files you write yourself. So you could open a new file, new text document, do the same thing, define some things, and then include it in your main document. If you want to include a standard library, you do these greater than or less than signs. These are called header files, so they will probably end with a .h, as compared to a C program that would end in .c. So if I go to my C program, let me just save this. I need to name this file .c in order for it to become a C program. And if I name this .h, it is a header file. But for now, let's keep it a text document so that we can edit it for now, because we don't have an editor. I'm just doing this in notes. So when we use these brackets, that means we're including a standard library. We're telling the compiler, okay, we want to put in a standard library, not one of our own libraries. If we want our own library, we go with these quotes. So yeah, you can include something like that. We'll look at some standard libraries later and what they do. But and notice that I put the include above and not below the main function. Why? Because I want the computer to read everything. So the computer is going to read everything from top to bottom. So it's going to read the main function first, execute it. But what if it's executing things that I have included in my library? Then it's going to try and execute that before it has it included. And that's going to give you an error. So you always want your include to be the first thing that you add in here, so that that can be loaded in, processed, and then you can execute your main function with all the things you have included. Yeah, that's it for now. Let's keep it short and sweet. There was a lot of kind of new concepts we went over here, but I'll see you in the next lecture then, I guess.